Hello guys, welcome on Tesla Adventures. In this video today we are going to start the heat and thermodynamics, and in this unit we'll be discussing the calorimetry, thermal expansion, KTG thermodynamics, and we would be going into the extreme depth of these chapters, and we would be presenting the videos till Olympiad level. So first of all, let us start from the basics of temperature. So temperature is a physical quantity that is related to the sense of hotness or coldness, which means that by the sense of temperature we refer something to be hot and something to be colder. And we know that temperature is also a physical quantity that decides the direction of flow of heat. In fact, we know that that heat flows from higher temperature to lower temperature. Okay, so temperature can also be defined as the physical quantity that decides the direction of flow of heat. So now a body which is having a higher temperature feels hotter as compared to a body which is having the lower temperature. Okay, so temperature is a quantity which is analogous to potential in electrostatics. Now we know that in electrostatics the direction of flow of charge is decided by the potential, and we know that the charge flows from the higher potential to the lower potential. In the same way, in thermodynamics, the direction of flow of heat is decided by the temperature, and the heat flow is from higher temperature to lower temperature, and hence we can say that heat flow is decided by the temperature. Okay, so first of all, you should know that temperature is a macroscopic quantities. It is dependent on the macroscopic variables of a body, and hence we can say that it is a macroscopic property. Now, any physical quantity that changes with the temperature is also called as thermometric property. For example, let us see that the mercury in the mercury thermometer expands due to the increase in temperature. Hence, we can say that thermal expansion is a thermometric property of matter, and therefore thermometric property can be used to measure the temperature. And obviously, we know that we are using the mercury thermometers to measure the temperature. Therefore, any thermometric property can be used to measure the temperature. Now, SI standard unit of temperature is Kelvin, and Kelvin scale is also called as absolute scale. And to convert the degree Celsius temperature into Kelvin, we need to add 273.15 in degree Celsius. For example, that if we need to convert the 0 degree Celsius into Kelvin, so we can add up 273.15 in 0 degree Celsius to get the temperature analogous to 0 degree Celsius in Kelvin. So we can say that 0 degree Celsius is analogous to 273.15 Kelvin in Kelvin scale. Okay, now let us see some temperature scales which are known to us. So we know that there is a temperature scale which is called as degree Celsius scale, and ice point is the temperature at which this ice water will freeze at this temperature, and boiling point is the temperature where water will boil. Okay, so we know that in degree Celsius ice point is 0 degree Celsius, and in degree Celsius boiling point is 100 degree Celsius, and the difference of boiling point and ice point is 100. So we can calibrate the complete scale of this degree Celsius scale into 100 equal divisions. Now Fahrenheit scale has a ice point of 32 Fahrenheit and a boiling point of 212 Fahrenheit, and the difference between these two extreme temperatures are 180 units. And Reaumur is a temperature scale which was used very earlier in 19th century and in the early of 20th century. So in this scale, the ice point is 0 Reaumur and boiling point is 80 Reaumur, and the difference of these two is 80 units. So what is the formula which is in interrelating these temperatures? So let us have a formula. So we know that any temperature minus the ice point of that temperature divided by the boiling point minus ice point. What we are doing, for example, let us see that there is a meter scale in which there are 100 equal divisions, and there is a centimeter scale in which we can say that there are 10 equal divisions for each 1 centimeter. So for 1000 centimeters, we can say there would be 100 centimeters, there would be 1000 divisions. Okay, so this scale is calibrated in centimeters. Okay, and we can say that one division of this scale has a value of 1 mm. We can also say that it is calibrated in mm also. So if we need to find out the length of any object by this scale, so let us take an example that if a scale is having a length of 50 meters, okay, so in meter scale its length would be 50 meter, and 50 minus the ice point, which is also the minimum division of this meter scale, which is 0 centimeter, and this is the number of divisions. So number of divisions is you know that there are 100 equal divisions on a meter scale, and each division has a value of 1 centimeter. So this is 100, so this is 1 by 2. And on the millimeter scale, you can see that this 50 is 50 centimeter is 50 into 10, because it is millimeter scale, and there are 1000 equal divisions on millimeter scale, so this again will be 1 by 2. So you can easily analyze this formula that the difference of temperature of any body and the ice point on that scale 2 divided by the number of divisions on the scale is always remains constant for any scale. So T minus ice point upon boiling point minus ice point will be constant for any scale. So for degree Celsius, we can say that the temperature in degree Celsius minus the ice point of this scale divided by the boiling point of this scale minus ice point. And likewise in Fahrenheit, T in Fahrenheit minus 32 upon 212 minus 32. And in Reaumur, T in Reaumur minus 0 upon 80 minus 0. And also in Kelvin, we know that ice point in Kelvin is 273.15. So T minus 273.15 divided by 373.15 minus 273.15. Okay, because 373.15 is 100 degrees Celsius, which is the boiling point in this scale. Okay, so this is the fixed formula. Now let us see that in this question you can see that we have to find out that what difference of temperature of 25 degrees Celsius is equivalent in Fahrenheit. So we can see that obviously T upon that boiling point minus that ice point. So T minus 0 upon 100 is equal to T minus 32 upon 180. So this is T1, this is T2. So T1 will be equal to 100 by 180 into T2 minus 32, and by differentiating we can see that delta T1 is equal to 5 by 9 into delta T2. Okay, and delta T2 will be equal to 9 by 5 of delta T1. Now delta T1 is 25, so this is 9 by 5 of 25, so it is 45 degree, in fact 45 Fahrenheit. So the correct answer is A. Now in this question you can see that there are three different temperature scales, and the freezing point and the boiling points of water on these three scales is indicated as shown. Now you can see that on these three scales the difference between ice point and boiling point and ice point is constant. It is 90 in this scale, it is again 90 in this scale, and it is again 90 in this scale. So this difference between boiling point and ice point is same in these three scales, and we have to rank the size of a degree on these three scales. So we know that if we are measuring a length 1 meter on any scale, then it would be constant, obviously, because that length will remain constant. But the reading of all the different scales would be different for 1 meter of that length. But obviously it is quite a common sense that the length of that 1 meter would be same on any scale, and obviously it is independent on the scale. So the rank of degree on these three scales would be equal. Now we have to rank the temperature, that which is highest and which is the lowest. So let us convert all of these three temperatures into degree Celsius. So we know that in degree Celsius T minus 0 upon 100 will be equal to, this is 50 plus 20 upon 90. So you can see that T will be equal to 700 by 9. Okay, and degree Celsius. And for second scale, T minus 0 by 100 will be equal to, this is 50 minus 30 divided by 90. So T will be equal to 200 by 9 degrees Celsius, and temperature in the third scale will be T minus 0 by 100, and it is equal to 50 minus 0 by 90. So again T will be equal to 500 by 9. So the greatest temperature is 50x, and then 50y, and then 50w. Okay. Now continuing further, we can discuss the thermometers. And thermometers are the devices which is used to measure the temperatures, we all know. And thermometers are based on the principle of some thermometric property that changes with the change in temperature. So the requirement of some good thermometers are following: that thermometer does not have a sticky substance which has higher value of adhesive force, because that force will restrict the substance to expand or contract. It should have the low melting point, obviously, because if its melting point is higher, then it may not show the correct reading. It should have the higher boiling temperature, and the coefficient of volumetric expansions should be high to increase the accuracy in measurement, because the lower value of volumetric expansion would skip the minute or the micro readings of change in temperature. Because if the coefficient of volumetric expansion is smaller, then for a lower change in temperature, the change in length would be negligibly small, which cannot be observed. Therefore, we would not be able to observe that change of length. Heat capacity should be low. Obviously, it should not absorb the heat and it should not rise its temperature. In fact, it should expand. The conductivity should be high, because due to the low conductivity, heat would not be transferred to the further parts of the material and it would not expand. And mercury suitably exhibits these all properties, so we use mercury thermometers. So these are some thermometers which are mentioned by with its range and thermometric property, which makes it suitable for measurement of temperature. So the first type of thermometer is mercury thermometer in the glass. Its range is minus 39 degrees Celsius to 450 degrees Celsius, and the thermometric property which makes it suitable for measurement of temperature is the expansion of the length of that mercury column in the capillary tube. Now next is constant volume gas thermometer. Its range is minus 270 to 1500 degrees Celsius, and the thermometric property of that thermometer is pressure of a fixed mass of a gas at constant volume, which changes with the temperature. Next is platinum resistance thermometer, which has a range from minus 180 to 1150 degrees Celsius. It works on the fact that when we change the temperature of a conductor, then its thermal conductivity and resistivity and therefore the resistance changes. Now, thermocouple was used previously many years ago, but it is not used now. So thermocouple has a range of minus 250 degrees Celsius to 1150 degrees Celsius, and it is based on the fact of the uh, generation of EMF when two different materials of metals are combined and their junctions are maintained at different temperatures. So due to the movement of electrons, EMF is generated. And this is the radiation pyrometer, which is suitable to measure the temperature of heavenly bodies like stars and suns. It measures the radiations and the color frequencies of the radiations coming from those bodies, and it gives us the reading on the basis of Wien's law. Okay, now let us see that this is a constant. This is a mercury thermometer, and you can see this mercury thermometer. There is mercury filled in here, and its initial length is always 0, and this is the highest reading, which is 100 degree Celsius. So we know that the temperature is proportional to the length, or we can say the length is proportional to the temperature of the thermometer of the mercury column. So if we will increase the temperature of the mercury column, then its length will increase because it would expand. So we can say that L is equal to some constant K into T, and therefore we can say that the quantity T minus T ice upon T boiling point minus T of ice point is equal to L minus L initial upon L maximum, which is at boiling point 100 degrees Celsius, which is Ls, minus this is 0, so it is Li. So T minus T ice is equal to T minus 0 upon this is 100, and this is L minus Li divided by Ls minus Li. So T is equal to L minus Li upon Ls minus Li multiplied by 100. So this is the calibration formula for this mercury thermometer, and this same goes with this constant volume gas thermometer. You can see that this is a constant volume gas thermometer. It consists of a gas filled in this bulb, and this tube contains the mercury. So we know that if we have to measure the temperature of this container containing a liquid which at some unknown temperature, so we will immerse this bulb into this liquid and it would expand, and due to its expansion, in fact it has the constant volume because it is a glass bulb, so its volume is fixed, and due to the change in temperature it would change its pressure. So the pressure inside this glass bulb would change, and due to that change in pressure, this mercury will be pushed into this tube and this height will change. So we have already created this formula on basis of the previous analysis which we have done in mercury thermometer. So this temperature is equal to P minus P initial upon PS minus P initial into 100, and we can write down this P in terms of H by using the formula H rho G. So this video was about the temperature scales and the temperature measuring devices which are thermometers. In the next video we are going to start the thermal expansion, which is also a quite critical and important topic of thermodynamics. Thank you.